Updating string. All right. Welcome to fact checking.
Hello.
So
Um,
that's Jaden. I'm Kip, and
hello.
we are scientists.
Okay. So, Kip,
Yeah, Jaden.
what first like ground rules? What exactly is a fact, and what does it mean by checking that fact?
So a fact, Jaden, is essentially anything that is true in all situations. So something that, regardless of what is happening, is truth.
Okay.
Uh,
So like I have this Smartie wrapper because I gotta prep myself party, and that's a fact, right? I have this here. I could take it to you, and this Smartie wrapper still exists. It's a fact that it is here and it exists. Is that right?
that is exactly right.
Okay.
Um, and so the checking part, Jaden, is checking to see if that stuff is actually a fact or whether it could be, you know, a truth some of the times, or maybe, a theory or an observation under certain circumstances. Ooh, we got a comment saying Freebird. We got to play Freebird tonight, apparently. Wrong channel. We don't do music here, Caleb Kaufman, whoever you are.
Well, thank you for joining us.
Yeah, thank you.
If you are liking what you see so far, go ahead, leave us a like, subscribe if you haven't already.
Yeah,
But
smash that
anyways,
like
you're
button.
telling us, yes, you're telling us the checking part.
Yeah, so checking is just making sure that something is a fact, right? Trying to figure out whether or not it is true in all situations or not. Uh,
Okay.
so,
Okay. So, what is a good way to actually check? What should
Jaden,
we
I'm
use?
glad you asked. If we move on to the next slide here, we've got something
Okay.
called the scientific method. Ooh, we've got quadratic formula. The quadratic formula, I believe, would be considered a fact.
Yeah.
Would you not
See,
agree?
you
You're the
could.
mathematician. Is it a theory or fact of math?
That is a fact, and you could actually look up proofs about it. So go ahead and type in quadratic formula proof, and you'll see a nice detailed proof. Maybe I haven't actually looked it up yet, but you might see a nice detailed proof about it, and it is a beautiful thing. But I don't think we're gonna prove that tonight, are we?
No, I don't think so. Um, Maybe we could prove that GameStop stock is gonna go to the moon, though. We can prove that tonight.
Yes.
To the moon, man.
Um,
Holden to the moon. Okay, we got mitochondria. That's Star Wars. I don't know if that's fact. Maybe in their universe, it is fact,
did you
but
say that's Star Wars?
oh wait, that's
Isn't the
metachlorians.
mitochondria? Isn't
Yeah,
that the powerhouse
yeah.
cell?
That's why Jake said powerhouse. Man, we got some smart people. We got hypotenuse. We have some smart people on tonight. They don't need
You
this
know.
lesson on fact check.
Okay.
Okay,
But
so
anyways, we move to this wonderful second slide that says scientific method. What exactly is that?
Jane, it's science. Duh. It's math magical.
Yeah.
Um, but going on, so the scientific method is a way to kind of prove facts. Ooh, yikes!
Okay.
Geez, Kip should really check his facts because I said that mitochondria is in Star Wars.
Star
They
Wars.
they probably do. It probably houses the midichlorians because it's the powerhouse. Anyways, Force
Sure.
powerhouse. Uh, anyways, so the scientific method is used to test facts, right? We use it in science, that's why it's called the scientific method, but it doesn't have to just be used in science. And so that's why we're going ahead and talking about this tonight.
So anybody can use it, not just scientists.
Anyone can use it.
Like
Anyone.
any Jim, any Joe, any Bob, any Jill.
I don't know about Jill. Jill's not allowed.
Okay.
Jill
So
needs to use
everybody
the Jill
excluding
method.
Jill.
Yeah.
Okay.
Okay. So moving forward. So first thing we gotta do, Jaden, is form a question.
Okay.
What?
What? Any question? Like,
Any
what
question.
time am I gonna go to bed tonight?
That
Like that question would
any
work.
question would work. Kelsey just asked, does anyone want some cake? That would work as well. That's a
Yeah, I guess
question.
so.
So should we make a
So
hypothesis? Does anyone want cake? What do you think? What would be the hypothesis of that?
my hypothesis would be, I. My hypothesis is I think somebody wants some cake.
Okay. Um, so you think that someone wants cake. So we had our question, and now we made a prediction, sort of. We made a hypothesis, right? What we think the outcome is going to be of that question. Okay.
So, well, I want some cake, so I think it's true.
It probably is true. Um,
Okay.
that being
So, wait,
said, but we need to make
before we,
predictions first.
yeah, before we move on, what is the difference between the prediction and the hypothesis? Because it kind of sounds similar just looking at it.
Hmm. It does. So the predictions are kind of like the things that need to be met for the hypothesis to be true, right? So the
Okay.
hypothesis is the outcome. The prediction is kind of what leads up to that outcome.
So, like maybe somebody has to be hungry,
Right.
uh, in a sweet tooth mood, and can't find ice cream or other desserts, but can find a cake.
And probably not diabetic.
Not diabetic.
Um,
Okay.
yeah. So those would be the things. So then we'd have
So those are kind of like our parameters, and we have to make predictions with those to test the hypothesis.
you're right.
Okay. Okay.
Okay. So now we have to test these kind of predictions, right? So we should
All right.
test it. Is anyone out there hungry? If you are, you should comment saying I'm hungry.
Yeah. Comment in the chat.
We got a lot of comments going on so far. It's pretty good. Um,
Yeah.
but Jaden's hungry.
Whoa.
Whoa, so someone's hungry. That's weird. So then we have to analyze it, right?
Okay.
Um, and we should test the other parameters. But we analyze it, and sure enough, lo and behold, Jaden's hungry. Jaden likes sweets. He's got a sweet tooth, and he's in a cake mood. So therefore, we proved that Jaden wants. Oh look, we got all
Uh,
sorts of I'm hungry's coming in.
yes,
I think there's some delay between us and them, is my
I
guess.
think so. I'm hungry. Very much hunger. Yes.
Yes, we got lots of
Agreed.
hunger. I have. That's good. So now we gotta analyze, and sure enough, lo and behold, people want cake. Did you guys want cake? Leave a comment. Let us know if our hypothesis was correct.
Yes. Okay. So I'm starting to understand why this scientific method is important, right? We can ask these questions to verify our own beliefs or prove wrong our own beliefs too, right? We can Yeah, we can test
Jaden,
any
I don't
question
want to
we have.
prove my beliefs wrong.
You don't? Why not?
No, because I believe them, dude. They're mine. I want to keep
Oh,
believing them. Um,
now you just sound greedy.
so,
Okay.
um, but, ooh, that's a good test. Ready? We have, yes, about 15 to 20 seconds, I believe. That's my hypothesis. Should we test this? Should we make I don't know where my phone is. Jaden, do you have your phone? Because we could test this. We could start a timer.
I have a watch.
Okay,
I'm
ready?
ready.
Okay,
Yeah.
so starting right now, Jake, respond when you hear this. Did you hit go, Jaden?
I did.
Okay.
Do, 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 do.
Anyways, but while we're waiting for that, so the test, it says best try to prove hypothesis wrong, right? So this is a very important thing. Um, and that's because if we're proving something to be wrong, then we know for
Uh-huh.
sure that it's not a fact.
Oh, we got an I heard. It was 26 seconds.
Wow. But I'm not Jake. Okay. So it was about 26 seconds to 30
20.
seconds.
So your hypothesis was wrong,
Yep. It was
but we
wrong.
learned from it, right?
We did. And we tested it, and we found a really easy test to figure it out. And now we know the delay is about 26 seconds.
Yeah.
Cool. So now we know, Jaden, we need to wait 26 seconds before we move on if we ask for comments. Okay,
Right.
so, but
So
yeah,
we're just in the prove yourself wrong. And Kip, why would you want to actively try to prove yourself wrong?
fake news. Um, we try to actively prove ourselves wrong because it's much easier, right, in a sense. So if we have a hypothesis, and the second we can prove that hypothesis wrong, we know that that's not a true statement. Um, and
Okay.
so
No matter what,
no matter what,
right?
no matter what.
Okay.
And so as soon as we find out it could be partially true, right? But if one criteria is not met while testing, then it's not true. It's not a fact. That doesn't mean
Okay.
some of the things might not be true, might be true. Um, and so if we also test it, if we have a hypothesis, right, and the easiest way to kind of start the testing is kind of try to test the most likely situation, right? And if we can find that in the most unlikely situation, something's going to happen, then that probably means there's a much higher chance that the likely situations are going to happen. So, we can move on to those tests. But if we start with the most unlikely situation and it becomes true, then that's when we can, kind of, I guess, I don't know. If it's not true, right, we've saved a lot of time as well.
Right. Okay. And then in the case that it is true, we would still need to test all the other situations too,
Right.
just to totally verify that our hypothesis is correct or not.
Right. So here's an example from
Okay.
geometry now, okay?
Okay.
So the question is it a square? I want you guys to go ahead and form a hypothesis about this. Is it a square? I'll give you a hint. You kind of have two options. It is or it isn't. Those are your two hypotheses. So let's see if we can get, it's like Team Edward, Team Jacob going on here, but team square, team isn't a square.
Team square, team square, 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 square.
So we have a question that says, at what point does a hypothesis become a theory?
Ooh,
This is my
that's good.
theory on that. I would argue and say a hypothesis is a theory, right?
Yeah.
Because a hypothesis is, we've got totally square coming in, but a hypothesis is an educated guess about something. We got team square, we got two team squares. So that's my personal belief. I don't know the
Yeah.
definition of theory, but
Isn't theory, has it been proved
it's
or is it still in the works?
still in the works. Once it's proven, it becomes a law at that point. So a theory is a theory until a law. We've got
So
Angie
we got a
saying that
rectangle.
rectangle, that wasn't one of the options.
It is square
Or
or is
isn't
not
square.
square.
I'm gonna guess that as is not square. Because a rectangle is not a square. However,
Well, I guess,
a square is a rectangle. So yeah, I
yeah,
don't
so,
think, yeah, I mean she's gonna be anyways. Yeah. Okay. Moving forward. Let's go ahead. We've got some people there. So
okay.
we're gonna say that it is a square. That's a hypothesis. Okay, we're part of Team Square.
Okay.
Okay.
Now we got to move on to our parameters for what a square actually is.
Jaden, you just cut out. Where'd you go? Jaden. Jaden. Oh, you're back. Phew.
Dude, I didn't go anywhere.
Yeah, so we've got these predictions, right? We're gonna predict that it has two sets of parallel lines. And then the lines make a 90-degree angle, and all four sides are equal lengths. Okay, those are our predictions for it to be a square. That's the definition of a square, or that's a definition of a square. Um,
Yeah.
so we got to go ahead and test this now. Okay, test time. First thing we're going to
So,
test is two sets of parallel lines. Jaden, what did we find
okay,
out
and
after we tested it?
whoa, holy moly, they are two sets of parallel lines. And you can tell by these cool little arrow V
You can
looking
draw on
things.
them, you can draw on it if you want. Look, these things
Oh,
right here.
right.
These. See, this means these
Yeah,
sides are parallel, and
and
this
these
means,
ones are parallel.
hey, back off. And those ones are parallel. Okay.
Yeah.
Oh, we got a comment here that says we need actual dimensions to prove that this is a square. Assume it is not to scale. So I think that's team it's not a square, which is I think honestly is a better hypothesis, right? Because you're you're kind of going from the devil's advocate perspective of, going against your beliefs in that sense, right? But we're gonna still
Yeah.
stick with team square. Okay.
Okay. So we tested our first, or we made our first prediction. We were like, hey, I think they are two sets of parallel lines. Boom, we tested that. We are so good. And we got two sets of parallel lines.
Yeah, we did. Okay,
Okay,
moving
now we
on.
should test our 90-degree angles.
Okay, so we've got parallel lines, check. Jaden, what did we
Check.
find out?
Oh my gosh, look, they are all 90-degree angles. We can tell because we have these fancy little square corners here.
Wow. So guess what? It makes 90-degree angles, so that is a fact.
Okay.
Just kidding. We're not to the fact yet that it's a square.
It
But
is a truth that those are 90-degree angles, though.
that is
true.
true. Okay, so we need to test one more parameter
Okay.
here.
Yeah, do you
So,
want to test them or should I test them?
what do you mean? Dude, I tested them already, way like 10 hours ago.
Whoa! They are all the same length.
Dude, they are all the same lengths.
Holy
Um,
moly.
Holy moly. So guess what? All four sides are equal lengths. When we know that because they're all written with this A, so side they all have the same length, A. We could throw in any number we wanted, and they would all be the same. Because
They
the
are
drawing is not to scale. So this could be 6 million meters. Who knows?
6 million meters.
It's a
Yes,
big
or it
square.
could be negative 100.
I don't think you
Oh,
can have a
it can't.
negative side.
Okay,
It de-
so was our hypothesis correct?
I would say yes, Jaden, that our hypothesis was correct, and this is a square.
Okay, it is a square. So that was analyzing our data, right? When we went through all these checks, we measured them, we figured out what they were, we analyzed them, we figured out that our hypothesis was correct from this definition of the square.
Perfect.
Cool.
Cool. So, yeah, should we keep going?
Yeah.
Or we got any comments? What do you guys think? Is it still a square? Were you guys right or wrong? Who knows? Okay.
Yeah.
But it is a square. No matter what situation is, this is always going to be a square, right? So that is a fact that this is a square. All right, so we're going to do it again now. We're going to go a little faster this time. Jaden, is it a square? Hypothesis, yes, it is a square.
I think this is a square. It looks the exact same, Kip. How would it not be a square?
Dude, I don't know, but let's find out, shall we?
Let's do it.
Okay.
Same parameters, right?
Same parameters. 2 sets of parallel lines. Lines make 90-degree angle. All 4 sides are equal lengths.
Okay.
We have a
Let's
comment saying
test.
easy to understand, good job. Thank you for that. Ooh, we got Team Rectangle this time. Clumsy Ninja
Ooh.
has switched to Team Rectangle.
Our question is still, is it a square or is it not a square?
That's true. They're not understanding. Guys, fun fact for all you watching out there, a square is a rectangle, and that is a fact.
That is. It has all of the same parameters.
It does.
Plus one.
Plus one. So, all right, moving forward. So we're going to test it. Jaden, guess what? Found out it has parallel lines.
Oh, heck yeah, it's a square, dude. Let's stop there.
Dude, you think? I mean, the last one had parallel lines, and it was a square, so I think we're good. We can stop.
Yeah. I think we better test the other 2 parameters. What do you think?
No, dude, I'm good. I believe it's a square, and I just proved it was, right?
No, Kip, we have 2 more parameters.
Oh, okay. Well, fine. Let's check the next one. Whoa, look at that. 90-degree angles. Are you going to say it's a square
What?
yet? Because I think it is. You said it
Dude,
looks
I
the same
think
as the last one, and it's acting the same way so far, so I think we're good.
Dude, I agree with you. Let's just end there. Let's call it a square, and let's just pack our bags, go home.
Yeah, I'm done,
No,
dude.
no, Kip.
Why not?
We have 1 more parameter.
Because that one might prove me wrong, Jaden. I don't want to be proved wrong.
But that's okay, Kip. That's the whole point, right? Sometimes our beliefs are not what they actually seem. Right? We believe that this is a square, but we gotta test all of the parameters.
Okay, we'll test it. Oh no!
What? A and B? B is greater than A?
Yeah, so are all the sides equal?
No.
Uh-oh. So Jaden, is it a square?
No, it is not a square. Even though our first 2 parameters checked off, we do not have a square here.
Dang. What do we have?
Not
Not a square. No, Jaden, we didn't test to see if it was a rectangle, though. We tested to see if it was a square.
I know.
So we didn't prove that it was a rectangle. We proved that it's not a square.
Hold up.
Okay, well, Jaden's doing something over there. The point of that was to show you guys that even if some of the parameters that we believed were true, not all of them were. So therefore, it was not a square. Our hypothesis was wrong. So now we're going to go ahead, guys,
All,
and do a little experiment with you guys. All right?
all
So,
together.
all
All
together.
together.
I wish I could see you all and know that you were doing this with us, but the all of us just, rubbing our hands together on a screen. Okay. So the question is why do hands get hot when rubbed together? And I want you guys to give us a hypothesis. And we know there's about a 20-second to 26-second delay between when people are watching this and
Right.
us. So we'll give it about a minute for people to come up with a hypothesis. Go ahead, comment. Why do you believe that
And while
when you
you're
rub your hands
commenting,
together, they get
go ahead
warm?
and leave that like.
Yeah, like and subscribe. Um, go ahead, share on Facebook while you're at it, since this is a live stream. Yeah. Are we assuming a frictionless surface? Caleb, the answer is no, we are not assuming a frictionless surface because this is a real world example.
Yes.
But good question. We are not in physics 1 or 2 right now. We are real life. We're going full engineer status right now. Just for you, Caleb.
Yeah. I do like how you mentioned friction, though.
Yeah. Wink.
Oink, oink.
Because I think we'd be in trouble if friction was not involved.
Yeah, that would be something.
So anyone got a hypothesis? Why do your hands get hot when rubbed together? If no one comes up with one in the next 30 seconds, we'll just have to go ahead and
We'll just have to do it for
yeah,
them.
we'll just have to do it for them. I think they're very capable, though. I believe that they can do this. Um, Anyways, also while we're waiting for people to come in with their hypotheses, um, for those of you that may be tuning in for the first time, this is not normally.
we got a, we got a hypothesis. We have two. Okay. I think it's due to little heat pixies that throw heat spells at hands when they're rubbed together.
That's a
Okay.
good hypothesis.
And
Um,
we have another one. My
yeah.
hypothesis is that my hands like being friends, so they get warm when they are close.
That's also a good hypothesis about when they're just close, but we're talking about being rubbed together. Hmm, that's good. Um, Along with that, Kelsey, I don't want to be rude, but we're supposed to be making educated guesses here. We forgot to add that part.
Yeah, that's an important part.
I mean, we can definitely try it, unless the pixies are invisible, and maybe they are. We don't see them, so that would be my. Do you see pixies, Jaden?
No.
No.
I tried really hard though. I believed they were there.
Well, that's important, I think, with pixies to believe. Correction, Kelsey. Very small pixies. Ooh. What if we call those very small pixies friction? That might be a good way to go. Um,
Yeah, like our atoms
yeah.
rubbing together.
Uh-oh, we got, can you prove me wrong right now? They are invisible unless you drink a special dairy substance. Okay, let's think about this. Let's think if we can prove her wrong.
Okay.
Okay, um, so if they're pixies,
Oh,
um, We
Yeah.
love the comments, guys. Tonight's great. We love the comments coming in.
Those elusive little guys. Okay.
So,
How are we gonna prove this right or wrong? So when we're testing, we want to actively prove it wrong, right? To get our best results. So
right.
let's try and prove it
Let's
wrong.
think. Let's find a parameter in which the pixies would not exist, but our hands would still get warm.
Uh,
Um,
about friction.
well, that's just proving friction correct. So let's
But
let's
wouldn't that
think a
also
little.
prove the pixies wrong?
It could, unless they argue that friction is because of pixies, which isn't, which could be true. I mean,
Yeah,
we don't
I
we
guess
don't entirely know. Um,
it might be a little particle pixies. I like that. I think it's true.
but I will say this. As we're going through this right now, Kelsey, there's one thing that you are doing incorrectly about your predictions about your hypothesis, which is you continually change it to make sure that it is correct. And the whole thing is
Yeah.
we're supposed to be trying to prove ourselves wrong. So just a little side note
So
there.
we've kind of actively proven that that hypothesis was wrong, but then she went and reevaluated to make a new hypothesis, right? So these pixies are now microscopic. We can't see them, or they're invisible, or now they're
Right.
friction pixies, or stuff like that, right?
Right. So this is um but let's take an example, or let's take this. I'm gonna um we're gonna say our hypothesis is friction, okay? So our hands um get warmer because of friction, all right? So there's a few parameters that we know about friction, okay? So parameter number one is that if we push harder, friction is stronger. So our hand should get warmer, right, from more friction.
Okay.
So here we go. Ready? So I'm going to start off kind of with low pressure, and I'm going to get harder,
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 harder.
harder, harder.
But I think we also went faster too, right?
Yeah, I know that was going to be the next parameter.
Okay.
So let's stay going slow and harder. Oh, look. It gets warmer the harder I push.
Yeah, so if we're moving this slow, lightly touching, but then we get a little harder, you can feel. Yeah, I
Right.
definitely
So unless
feel.
the pixies know how hard we're pushing, then that proves the pixie theory wrong because it was
True.
all based on us. So the next thing we can do is we could say, okay, with friction, the more friction, right? So the more our hands travel over a certain amount of time, the hotter they will also get. And the way to make something travel over time faster is to speed things up. So if we go like this, faster and faster and faster, whoa, my hands got even hotter.
Oh, oh, oh!
So
It's
did
hot.
that prove that friction um, is what causes our hands to get hotter?
If those are the only two parameters, then yes.
That's true. Do we even... I think it's true. It's a fact.
Yeah.
We at least proved the pixies wrong because the pixies, we have a statement that says, I don't know if the pixies know that or not. So because they don't know that or not, then that can't be the reason why. Everything we're doing to make our hands warmer is based on us, right? So that kind of
Yeah.
proves the pixie theory wrong. Okay, should we keep moving forward?
Yes. Okay, so that was our little hand experiment
So
where
we
everyone could
have a
participate.
question. This is actually a really good question that says, how does one decide on parameters?
Ooh,
Ooh.
that is a good question.
Um, so my so in the um, parameters for this experiment, for example, and in the past one, they are things that have been proven as fact before, right? So friction has certain properties about it
Hmm.
that we know for a fact, right? So the harder a force is pushing onto something, the stronger the friction. That is a fact, okay?
Yeah.
And so that is a parameter which we already know. So kind of, I guess parameters are almost like past hypotheses that have been proven correct, right? And so we kind of build, we almost a hypothesis is almost like one more parameter
Right.
based on past knowledge.
I know in math, like at the very base level, we set up axioms that are like the very basic things. And then you have to prove everything on top of those axioms. And you can use those proofs to build and build and build. And then that's where we get these really complex proofs about like the quadratic formula, right? Like that would be a more complex proof. One is greater than zero sort of proof. Does that make sense?
Right. Yeah. So that's how you get the parameters. And if things have already been proven in the past, then you don't need to go back and reprove them again, right?
Yeah, you
Because
don't have to start at the
if a fact is a
foundation.
fact, like we said, it is always there. It's always going to be there. Um,
Yeah.
and so you don't need to reprove that fact over and over again. So that's a great question. Thank you for clarifying. We have a hello.
Hello there.
Hi, Mia. Thanks for joining. Okay, so we're going to keep going on, and we're going to move on to our in history segment. Okay,
Right.
so Jaden, do you want to
So
talk about this one a little bit here?
sure. And if you feel like you need to say anything, just jump in, okay, Kip.
Okay, I will
So,
jump in.
so in history, most of us, I'm sure all of us, I don't know, this could be tested, but a lot of us have heard of this scientist, Albert Einstein.
Dude,
Okay.
wasn't he super smart?
He was he was a pretty smart guy. He had a lot of theories that are relevant today, and he's proven a lot of stuff also. Um, but that's not what we're going to talk about. We are actually talking about his biggest blunder. That's what he called it after he figured out he was wrong. So
Wait,
he,
Einstein was wrong?
yeah, it happens to all of us,
Dude,
right?
I'm never
Even
wrong,
the
Jaden.
smartest
Ask
people.
anyone in the chat if I've ever been wrong.
Well, I'm in the chat. Okay. Uh, but yeah, go ahead, chat. Talk about Kip and how wrong he is a lot of the time. Uh, and I'll keep explaining Stein and what one of his beliefs was. So he believed that our universe was static, meaning that it never expanded or contracted. It had the same volume forever, in like for eternity. It was going to be same volume, never changing. Uh, that doesn't include the like rotations of galaxies and stuff like that, because that can still happen and still have the same volume. Okay, so that's what he believed. And then we got this other smart guy, Hubble. You might have heard of the Hubble telescope that took a lot of cool pictures of the night sky. He was thinking, well, Einstein, I don't know if I really believe that this is going to be static. And can you imagine Kip going up against Einstein? This
Dude,
guy, smart.
I could not. I mean, Einstein's a genius and he also, helped create the atomic bomb, so I wouldn't want to fight. Gets the man that created that is all I'm gonna say.
Yeah,
That's some scary stuff.
but anyways, this guy was gutsy and he did it anyways. So he was thinking, well, I want to basically prove Einstein wrong that it's not a constant volume. So he wanted to check if the universe either expanded or contracted, right? So he was able to do this by discovering the redshift.
So
And
let me get this straight, just to be clear.
yeah,
So Einstein's hypothesis was that the universe was constant. The volume was constant, right? So Hubble didn't need to prove whether or not it was expanding or contracting. All he needed to do was prove that it was not
changing.
constant, right?
Yep,
And it
yep.
didn't
All
matter,
you need to do is
and that would
just
prove
change it,
Einstein's hypothesis incorrect.
right? Whether
Okay.
it be changing like a weird peak, expanding just in one spot, right? That would have done it too, right? Or if it was contracting in just a weird spot, that would have done it. But anyways, he figured out that the universe is actually expanding due to this red shift that he discovered. Uh, and
Dude, the
this,
redshift is cool for anyone that's wondering. You can go look
yeah,
it up, but it's essentially because the stars, galaxies, everything are moving away from us. It
uh,
actually stretches out the wavelengths of light, and longer wavelengths are more red. So when you see a red shift, the what you think the wavelength of light should be is actually longer than it should be. It's not that everything actually looks red per se, but
yeah,
it's
it's
more
not,
red than it should be. Um,
yeah, yeah.
so
Thanks for clarifying that.
you're
So,
welcome.
anyways, later Einstein was like, yeah, you're right. You proved me wrong. This was my biggest blunder that I've done. Basically, thank you. Let's move on. I'm still smart. I'm going to figure out more stuff.
But Jaden, he got something wrong. How could he still be smart?
So I'm sure he knew that like it's okay to be wrong in your like scientific theories and beliefs, right?
What?
It's
It's okay to be wrong? You
yeah,
like my
yep.
acting, dude? Should I become an actor?
What? No way.
Dude, I think you did
Yeah,
better than me. That was a better audition tape for sure.
dude. I think we should both try out.
Okay. For sad
Yeah,
Einstein who was wrong.
yeah.
Okay.
So this just shows you even the world's smartest people use a scientific theory and scientific method, sorry, and are wrong sometimes, right? Their hypotheses are wrong sometimes. So it happens to everyone, uh, even Einstein.
Yeah. And so the interesting part about all this, I think that's kind of intriguing, is that we know that the universe is expanding, but we don't necessarily to know to what extent, and we don't know if the whole universe is expanding still, right? But it just proved Einstein's theory wrong that it is completely static, right? That there is, anyways, there is some movement in the volume of the universe. And so
Yep.
Hubble proved it wrong, but it still is a theory as to, what that movement is and all sorts of different things. And so there's still a lot more of study that needs to go on.
Yep.
But because Einstein's theory had all these check boxes and Hubble was able to prove just one of them wrong, that means that the whole theory, needs to be reevaluated.
Right.
Um, and the fact that Einstein was willing to accept that he was wrong is something very important. So now we're going to move on to how does what we just talked about, Jaden, help all those that have been watching?
So it would help me personally in just like in my sciences, right? In my math and my physics, I can anytime I ask a question, right? It would also help me if I'm trying to check with political beliefs or religious beliefs, right? Any of these, you can use a scientific method. Any question you have, you'll be able to use this. Uh, and as long as you follow correctly, you can answer these questions, right? What
Right.
about you, Kip? How would it help you?
Um,
Or how does it?
so yeah, in today's world, we live in an interesting world today where um, social media and other things exist out there where people
Good
can
point.
say whatever they want, which is great. Um, we have the Red Shift, Tom Clancy's post. I can't read. But yeah, sure. I don't think that's true, but maybe it is.
Who knows?
Who
That
knows?
was
It does
from
sound like a
Craig,
good
so
title. Yeah, you'd never know. Um, but anyways, like I was saying, so social media, other sites, they don't have the same ability to fact check, right? And people can say whatever they want, which is great. It is so important that we have freedom of speech and be allowed to say whatever we want,
right.
because it allows, it allows things not to be hidden. But when that happens, we still have this issue where we have to be able to discern what is truth, what is fact, and what isn't. And a lot of things are opinions, right? And they're not fact, but they can be stated as fact. And so we can go through using this scientific method,
Tallest person ever. Fact.
not fact. I think the tallest person ever was like 9 feet tall, probably, or something.
Dude,
I don't know.
I could write it on social media, whatever I want. It's fact.
Okay, well, I'm going to use the scientific method and prove you wrong.
Okay.
Um, Jaden's using a great example here. So yeah, that's kind of the whole premise of this is that, especially if it's something that I believe personally, right? That should be a red flag that it's time to go fact check. Um, because it's so much easier to just jump on board with something that we believe. That's something that fits with our values, to just automatically go, yeah, that's truth. Um, but we actually have to go and try to prove it right or wrong. And like I said, it's better to try to prove yourself wrong than right. Um, because if you're trying to find parameters in which it's not true, it's much more effective than trying to find parameters in which it is true. Um, because it helps you kind of decipher quicker and easier the truth behind something. So, for all you people out there, go fact check using the scientific method. It'll help you discern what is truth and what's not. And I highly, highly recommend you go do this on things that you disagree with as well. So, with the things you believe with in and the same things you disagree with. If someone says something and you believe it's
Yeah.
outlandish and you disagree with it, go look into it. Use this method, and believe it or not, you'll actually probably find that there's a lot of facts in what they have said. It may not all be facts. And you'll realize pretty quickly that the facts that they said are the same facts that you believe in as well.
Yeah.
So there you go.
Well said. Well
Thanks,
said.
Jaden.
Yeah.
So I feel like we're having a lack of subscriptions and likes during this live stream. So if you haven't liked and subscribed, you should go ahead and do that.
Yes, please,
And
and thank you.
yes, please, thank you. And then on top of that, this isn't normally what we do here on this channel. Normally, we just hang around and answer people's math and physics homework questions or anything they may be interested in learning about or maybe stuck on in school, need some more help. So if any of you guys that are watching have any, uh, you know, those, I guess, have any need for help in math and physics, please tune in every
Or if
Tuesday
you
and
know
Thursday.
anybody that does.
Yeah, or if you know anyone that does, let them know about this. Every Tuesday and Thursday at 8 o'clock, we do this. So, and you can continue to watch us anyways, even if we don't,
Oh,
because
okay, but lost
you
you.
can watch us.
Tip.
Jaden, you lost me? Jaden,
Oh,
you're frozen.
I'm here.
Okay, oh
You
phew.
were frozen.
Anyways, for those of you that might, um, you know, just want to watch us struggle through math and physics too, you can do that because I guarantee you we do struggle quite often. Um, so it's good
Okay.
entertainment. But
Oh yeah.
all right, well, anyone got any questions? If not, we will go ahead and end this. So thank you all for watching
Should
and
we wait
tuning
that
in.
like 30 seconds?
Dude, I'm trying. That's why I'm stalling, Jaden. Don't you see how slow I'm talking?
Yeah, super slow.
Slow.
Okay, well,
Hey,
yeah,
Jaden, quick question. What's the blue shift?
blue shift would be on the opposite end of the light spectrum where things would be coming at you. It would be contracting instead of expanding.
Oh, cool. Thanks. All right. No, that's good. Thanks.
Yeah, you're welcome.
All right.